All right, so yesterday we covered the word equilibrium a little bit further. Okay, so we had a definition that told us that a forward and a reverse reaction were happening at equal rates. Good, okay. Then we went over an equilibrium equation. I'm just going to do this. But it's not equilibrium. It's equilibrium equation. So that was just telling you that you could have some sort of a balanced equation with a little arrow like this in the middle, right? And they had coefficients and stuff. Then we went over an equilibrium. All right, the equilibrium expression, which was the K is equal to, and then we had products over reactants all taken to their little coefficients, right? So that's what was in our warm-up today. All right. And then finally, you guys also talked about K being greater than 1, and that was favoring one or the other. That was, I think, when you guys were walking out. And then K was less than 1. So let's just quickly review what that meant. If we have K being greater than 1, who are you favoring? You're favoring your products, okay? And your proof on that one, the numbers that I told you to think of was 1/2 versus 2/1, right? And if that is products over reactants, okay, this meaning we have more reactants, that's equal to something that's less than 1. So when we have less than 1, we're favoring your reactants. The one on top was greater than 1, which is true right here, so therefore we had more products, or we're favoring our products, okay? All right. So we had that, and then we had those couple graphs. One thing I want to point out on the graph from yesterday was that we had one that had concentration versus time, and it kind of leveled out like this, right? And they didn't have the same thing. The one that had the same was going to be the reaction rates, which is what we want, rates to be equal. Concentrations, we just want to see them level out to where when we look at a reaction happening in front of us, things don't look like they're changing anymore. And that's equilibrium. Okay? All right, so that was all yesterday. So today we're just going to make our notes on Lechathlier's principle official. So you can go ahead and title yours. Lechathlier's principle, I assume. All right, so for this principle, okay, you guys were doing an entire POGL on things shifting left and right and all that business. What did that all depend on? Pressure, temperature, concentration, right? Those were the things we were messing with. So you're changing conditions. So this is just stating that changes in conditions such as, what is the brackets again? Molarity, concentration, good, okay. Pressure or temperature will cause a shift in equilibrium. Sorry, I'm not done yet. In order to offset that change, or what we said this morning was find balance, okay? Or to reestablish equilibrium. Any of those are, it's all talking about the same thing. So basically we have something that's in equilibrium, we mess with one of those conditions, and it goes crazy. It's like, I'm not in equilibrium, and then it has to find its balance again by going left or right or left and all that good stuff. And then it finally finds balance and everything's happy again, okay? Until you change a condition again, and then it has to work to get back to being balanced, all right? Does that kind of make sense? So like if you're trying to balance on one foot and somebody like kind of pushes you a little bit, you're gonna kind of turn towards it so that that little push is pushing you this way, and you're trying to offset that little push. Do you guys kind of understand what I'm saying? Yeah. Okay, or if you make Kool-Aid and it has too much water in it, what are you gonna put in it? Sugar. You add more sugar to it, right? To offset that. Okay, Got it? We all got the idea? So we're going to go back to our equation that we had in the warm-up, which was that N2 plus 3H2. And we're going to have our little equilibrium arrow, 2NH3. Okay? Okay, so we're going to kind of refer to this, and I'll flip it for one of them just so you get something different from what we did earlier. But we're going to talk about probably the easiest one in my opinion, which is concentration. Okay? So for concentration, okay, we know that if we increase a reactant, so who are my reactants right here? N2 and H2, right? Okay, so if I increase the reactant, which way is it going to shift?
To the right.
Good. It'll shift right to offset that, right? Okay. And then if I decrease one of those reactants, it's going to shift what? Left. Okay, so what I like to refer to is, what kind of analogy do I kind of keep bringing up?
Kool-Aid. Oh.
All right, when we were talking about lechatlier, I kind of told you to think of a what? Do you guys remember? A seesaw. You guys kind of remember me? Never. All right, well, now I'm going to tell you a seesaw. All right, I did say that yesterday. Cool. All right, so with a little seesaw, what we're looking at here, if this is my little seesaw, and you might draw yourself a little seesaw. So here's my little seesaw, okay?
Yeah, right.
There's my seesaw. All right, if I increase the reactant, we know my reactant is on this side, and we know my product is on this side. So if I increase this side, it's now going to look like that. Do you agree?
Yes.
Yeah. So if I had a nice little random ball on this little seesaw, which way is that ball going to roll?
Down.
It's going to roll down the ramp, all right? It's going to roll down to the what?
Right.
To the right. Is that not what we said over here?
See?
Yes, all right. So I use the seesaw analogy. So when we increased a reactant, it headed to the right. When I decreased the reactant, which way did it head?
Left.
To the left. So, in summary, okay, so with this little seesaw, we said if I increase reactants, it's going to roll to the right. If I decrease reactants, it's going to roll to the left, right? So really what's happening here is that with concentration, okay, if I increase concentration, it shifted away. And if I decreased concentration, it shifted towards. And what we're going to see, we're going to put that into a nice little cloud here, okay, because we're going to use that same idea for the rest of these notes. If you increase something, it'll shift it away. If you decrease it, it's going to shift it towards that, okay? Because what we're going to do with our pressure and temperature is we're going to now make them a character, okay? Okay. All right. So, I'll leave that up here so that we can kind of refer to it. All right. So now we're going to talk about pressure. Okay. So for pressure, you have one little step to do beforehand, which was, what did we do in the warm-up? What did we have to look at? We had to count up something.
The moles.
Right. Okay. So you had to count moles on both sides. Okay. And when we counted moles, what were we actually counting? What did we? Coefficients. Good. So you add up coefficients. Okay. And then once we do that, what Miss Vogel did was I put a P on the side with the most. So place a P on the side with the most. Because now what we're doing is we're making it one of the characters. And now we're going to treat it the exact same way that we did with those concentrations in the last problem. Okay? So let's use that similar example from earlier. Okay? I'm just going to reverse it so it's a little different from your warm-up so that you don't just say what you did earlier. So we're going to make it backwards. We're going to go like this. Okay, so looking at this, and these are all gases, okay, we're going to count up our moles. So we said, how many did this side have over here? 2. How many does this side over here have? 4. Okay, so we're going to pick the side that has the most, this side, and now I'm going to add a P to it. Okay, and I'm going to make that a different color so it looks a little different. All right. Okay, so now what I'm saying is, now if I ask if pressure increases, it's like increasing the concentration of P, basically, okay? So we can say if I increase P, referring to our little seesaw thing again, okay? If I increase P, he's on the product side, that ball is going to roll to the left, okay? So it'll shift left. If I decrease P, then that ball is going to shift to the right. Okay? So, use the seesaw. Okay? So what this means is that, once again, we're going to be seeing this thing, this little relationship up here. We're going to say if I increase P, it shifts away. And if I decrease P, it shifts towards. Does that kind of make sense? So it's looking the same thing, like the same thing, okay? So we have the same little idea here. Do you need help with it? Oh. All right, so for temperature, we're going to do the same thing, okay? But this time we don't have to count up moles. This time you have to ask yourself this question. Is it endothermic or is it exothermic? And for the most part, we'll tell you, okay? Or somewhere in your balanced equation, we're going to add some heat somewhere. So if heat is a what? Reactant or product when it's endothermic? All right, so heat is going to be a reactant if it's endothermic, right? So it enters the relationship. God bless America. It enters the reaction, right? So endothermic. Exothermic, it's exiting. So therefore, heat is a what?
Product.
Is a product, okay? And one thing that I want to point out is that sometimes we won't use the word heat. Sometimes we'll use energy, or sometimes we'll just put in a number and put 50 kilojoules, whatever, okay? So just be ready to see that for heat. Now, once you've decided if heat is a reactant or heat is a product, you're going to put a T there, okay? So just like what we did with the P. So, when we have an endothermic, it would look like this. So we would have heat plus a that, okay? So here it's a reactant. So what I'm going to do is I'm going to go right over the heat and I'm going to put a big T. So now I just made it one of my reactants. So once again, if I increase temperature, that little seesaw is going to go like that. So the ball is going to roll to the right. So it's going to shift right. Okay. If I decrease temperature, I'm going to try and draw these fast. You do not have to draw the seesaw if you get it, by the way. Okay. You are going to shift left. Okay. On the other hand, if I have it as a product, we now have A, forward, backward arrow, B plus heat. So if I increase temperature, that means that I'm increasing the product side. So I'm going to shift left. and the opposite is true. Okay, so once again, what we're seeing here is that if I increase temperature, it shifts away. And if I decrease temperature, it shifts towards. So hopefully that helps with not having to memorize all of those little facts. If you can just think of the seesaw thing, you'll know which way it's always shifting. It always shifts away from the increases and shifts towards the decreases. Okay?